Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alia Natasha binti Muzid and I will present about the introduction. So, this task presents a linear programming model to help a farmer maximize seasonal profit by deciding the optimal acreage for chili, tomato crops. The model defines a decision variable, sets a profit maximizing objection function, and converts resource limits into linear constraints. Using the graphical method, the constraints are plotted to identify the feasible region and the corner points are evaluated to determine the acreage combination that yields the highest profit. The goal is to develop an accurate LP model and identify the optimal profit and planting plan
So next
for
for
both.
the question, my name is Norharani bin Darul. So for question 1, the farmer wants to plant chili and tomatoes, but he only has limited labor hours, fertilizer and pesticide. Our task is to build a linear programming model to maximize his profit. So let's X be the acres of chilies and Y be the acres of tomatoes. The profit function is P minus 3500x plus 2800y, which we want to maximize. And all the limits from labors, fertilizer, and pesticide become our constraint. Next, for the question 2, we solve the model using the graphical method. We plot all the constraints, find the feasible region, look at the corner points, and calculate the profit at each one.
My name is Irene Sofia and I will present about the equation solution for the question 1. Our objective is to maximize profit represented by the function which is z equal to 3500x plus 2800y. And this means each unit of chili contributes to RM 3500 and each unit of tomato contributes to RM 2800 to the total profit. However, we face three resource constraints, which is the first one is labor. The constraint is 5x plus 3y less than 200. Number 2 is fertilizer. The constraint is 4x plus 2y less than 150. And the last one is pesticide. The constraint is 2x plus 3y less than 120. And these inequalities ensure we don't exceed the available resources. And to solve this graphically, we calculate the intercepts for each constraint by setting the x equal to 0 and y equal to 0. And based on the table given in the slide, the first equation is 5x plus 3y less than 200. The coordinate for the y will be 66.67 and the coordinate for the x will be 40. Next constraint is 4x plus 2y less than 150. The coordinate for the y will be 75 and the coordinate for the x will be 37.5. The last one is 2x plus 3y less than 120. The coordinate for the y will be 40 and the coordinate for the x will be 60. And all of these points help us plot the constraint lines and identify the feasible region in the graph given. Thank you.
Assalamualaikum. My name is Maria Rashika binti Hazi Faizal. So I will be continuing for question 2. So for question 2, we put each graphical line based on the equation point of x and y. So the first equation with the purple line is 4x plus 2y less and equal to 150, which indicates the area is less than the line and moves to the left downwards. So the second equation with the blue line is 5x plus 3y less and equal to 200, which indicates the area is less than the line and moves to the left downward. And the third equation with the red line is 2x plus 3y less and equal to 120, which indicates the area is less than the line and move to the left downward. So to summarize, all equations are moving left downwards and followed with x and y greater and equal to 0, which means that all overlap areas are equal and not more than 0. Based on all overlaps area, we have created a feasible region. So the first corner point of this feasible region is 0 and 40 and followed by 26.25, 22.5 with the third corner point of 37.5 and 0. So To solve the intersection point between the first corner point and third corner point, we have to calculate between both equation. So to find the right intersection point, we must calculate between the first corner point equation with the third corner point equation. So the first corner point, 0, 40, with the equation 2x plus 3y equal to 120, while the third corner point 37.5 and 0, which the equation is 4x plus 2y equal to 150. We times 2x plus 3y times with 2, we can calculate until get x to 26.25 and y 22.5. So both of the point is the correct answer for the intersection point in the feasible region. That is all for me. Thank you so much.
To determine the maximum profit, we use the corner point method of linear programming. First, we identify the vertices of the feasible region shown on the graph, which represent the only point where the optimal profit can occur. Those points are 0, 40, 26.25, 22.5, and 37.5, 0. We then substitute these x and y values into our objective function, which is z equal to 3500x plus 2800y. The resulting profit are 112,000 ringgit, 154,875 ringgit, and 131,250 ringgit respectively. And by comparing this outcome, we conclude that the maximum profit is 154,875 ringgit, which is achieved when the production level are x equal to 26.25 and y equal to 22.5.